In 1.3, we're going to be finding limits from the graph, but we're going to add one-sided limits to what we learned last class. Okay, so for one-sided limits, this is the notation we're going to learn. The way I say that, or what a one-sided limit is, f of x is the y value as x approaches c from the left or from the negative side. So this little negative here is just telling you which side we're approaching c from. So that this is the limit as x approaches c from the negative side of f of x. If there's a little positive side, a positive sign, its limit as x approaches c from the positive side of f of x. And that's going to be the y value as x approaches c from the right or the positive side of the graph f of x. So we're going to look at example 1, where they already gave you the answer. They just want you to fill in the notation, and then we'll look at the graph to make sure this is in fact true. So this says the limit of f as x approaches 3 from the left side is -1. So first I'm just going to do the notation. So I'm approaching 3 from the left side. So I'm approaching 3 from the left side is the negative side. And it tells me the answer is -1, but I'm going to go back to the graph so I can confirm that this is in fact true. So at x is 3, I can see there's this graph and there's this piece of graph over here of f of x. Okay, I want to approach 3 from the left side. So this is the right side of x is 3. This is the left side of x is 3. Okay, if I go on this piece of graph, the y value appears to be approaching -1, so that's where they're getting the -1 from. Okay, let's look at the next one. The limit of f as x approaches 3 from the right side is 2. Okay, so I'm at x is 3 again. The right side of x is 3 is over here, so that must be looking at this piece of graph. Okay, let me write that down. So x approaches 3 from the right side is the positive side, and it's going to be 2. Okay, on this piece of graph, at x is 3, or as I get close to x is 3, it looks like the y value is going to be +2, which is why they're putting a +2. Okay, now the question is, isn't it weird that two sides are different? Yes, it matters when I evaluate the limit as x approaches 3. So as x approaches just 3, and it doesn't tell me what side. Okay, if I look at the graph at x is 3, the graph looks like it's approaching 2 from up here, and then it's approaching -1 from down here, so it's not clear to me what it's approaching. It's not approaching one defined value. So the limit does not exist, and the abbreviation for does not exist is DNE. Okay, and the reason it does not exist is because as x approaches 3 from the negative side, it equals -1, and x approaches 3 from the positive side, it equals 2. So the left and right limits do not match, which is why as x approaches 3, the limit does not exist. And if you look at the graph, you can tell it's just not approaching one singular y value, so it's really hard to read. Okay, for the next example, we're just going to look at the graph and try to evaluate the information. Okay, so let's look at A. A says as x approaches -2 from the negative side. So x is -2 is over here. The negative side is the left side. So this is the right, this is left. So I'm looking at this piece of graph. So if I come from the left side, it looks like the y value is going to approach 1. So I put a 1 there. And it doesn't matter what it actually equals, it matters what it's approaching. And now what if I approach -2 again, but this time I come from the positive or the right side. So at x is -2, if I come from the right side, I'm over here. Okay, if I come this way on the graph, it looks like the y value is approaching -2. And it doesn't actually equal it, but it's approaching it. Okay, now what's the limit as x approaches -2? Well, at x is -2, one piece looks like it's going up here, one piece looks like it's going down here. Since the left and right behavior do not match, this limit does not exist, or DNE if you're lazy. Okay, let's keep going. Okay, this one says the limit as x approaches 1. So at x is 1, right around here, the graph appears to be approaching y is 1. It doesn't actually equal to y is 1, but that's what it looks like it's approaching, so that's what the limit's measuring, what it appears to be approaching. Okay, the limit as x approaches 0. So at 0, that would be down here. The graph's actually continuous there, so at x is 0, the graph looks like it's going to -2, and it even equals to -2. Okay, let's look at x approaches 3. Where's 3? 3's up here, 3's over here, and I'm going to come from the negative side, which is the left side. Well, let's see. X approaches 3. The limit as x approaches 3 is 5. If I come from the left side, it's still going to be 5. No matter which way I come, it's actually going to be 5. Okay, as x approaches -1, that's down here on the graph. As x approaches -1, it looks like the y value is approaching -3. Okay, then the last two are using the function notation. So this is f of 1. So I want to see what the actual y value is at x equals 1. Don't care about the limit or the rest of the graph. I care only about that one singular point. So at x is 1, the actual point is that point down there. So at x is 1, the y value is actually -2. And this is another way of saying the point 1 comma -2 is on my graph. Now I'm disregarding the rest of the graph. Okay, at f of -2, at x equals -2, what is the actual y value? So where is there actually a point? This is the point that matters because it's a closed circle. So -2 comma 1 does exist on the graph, and f of -2 is equal to 1. And I don't care about the rest of the graph when I'm evaluating the f of -2. Okay, the last example, they're going to give you a description, and you're going to sketch a graph of g that satisfies those conditions. And there could be more than one answer here as long as it meets all the requirements. So I'm going to go through it and kind of pencil it in, and I'll go back and fine tune it. Okay, this is going to be a graph of g. The first thing they tell me is that g of 3 equals -1. Okay, g of 3 equals negative tells me that 3 comma -1 has to be on the graph. So that is a for sure point. I know that's correct because it has to be on the graph. Okay, now it's telling me the limit as x approaches 3 of g of x is 4. So as x approaches 3, my graph should be way up here. Okay, let me think about that. Okay, let me kind of think. Okay, I don't know what the graph's going to do. Maybe it's going to go this way. It should be going to 4. Now, what actually happens at x is 3? I can't put a closed circle here because there's already a point down here and it will fail the vertical line touch. So I'm going to put an open circle here. And then I'm just going to scribble in a random graph, even though I'm probably going to have to erase that later. Okay, so this was the limit as x approaches 3 of f of x is 4. So at x approaches 3, the y value is approaching 4. But I still have this point down here. So I'm good so far. But again, I'm going to have to go back and fix it probably. Okay, the limit as x approaches -2 from the positive side is 1. So at -2, the positive side is the right side. The graph should be going to 1. So from here, on the right side, it should be going up here. Okay, let me think. It doesn't tell me if it's going to equal that or not. So I'm going to just do it open for now, and I'll go back and fix it. And let me fix this a little. It's going to go up here somehow. So maybe it's going to go like that. Okay, I'm going to leave it tentatively like that, and then I'm going to go to the next piece of information. Okay, g is increasing on -2 is less than x is less than 3. So the graph is the y values are going uphill from -2 to 3. So let me look. So from x is -2 to x is 3, the graph should be increasing only. This one kind of looks like it's going down here a little bit. So let me adjust this. Okay, so I want it to only increase. So let me try to make it go like that. So it looks like the whole time it's going uphill, whereas before it looked like it had a little hump. Okay, let me read the rest of the information. Okay, the last piece of information. The limit as x approaches -2 from the negative side is greater than or higher than the limit as x approaches -2 from the positive side. Okay, so at x is -2, from the positive side, I already have it equaling to 1. The negative side must have a y value that's higher than 1 then. So it could be here, it could be anywhere up here. It doesn't tell me, so I'm going to pick a random point up there. Okay, it doesn't tell me if it's open or closed either, so I'm going to go ahead, I'll just make it closed. Since the other one was open, this could have been closed and this could have been open. It didn't tell me, so this can meet the requirements either way. Okay, since this is a limit, there must be some kind of graph over here. It doesn't tell me what kind, so I'm just going to put some random graph. Okay, and then let me finish off the graph on the right. It probably has an arrow. And then I'm going to go back through the list just to make sure everything works. Okay, g of 3 is -1. Done. The limit as x approaches 3 of g of x is 4. So as x approaches 3, the y value is approaching 4. And I did an open circle because this already had a point down here. Okay, if x approaches -2 from the positive side or the right side, the g of x should equal 1. So -2 on the right side, it's going to 1. Okay, I made it open, but it didn't have to be. G is increasing. -2 is less than x is less than 3. So from -2 to 3, the graph should be going uphill, which it is. And the limit as x approaches -2 from the negative side should be higher than the positive side. So on the left, this point, this graph, this limit should be higher than this one, which it is. So I've met all the requirements, but remember, this is not unique, and as long as your function is meeting all the requirements, then it's a good graph.